So let's start from here. So how will you do? You will calculate is 1 over 2. You will put x1 over here, and then you will delete this, and you will get y2 minus y3, and then minus y1, and then you delete this, so you get x2 minus x3. Then you have this plus 1. That means that you have x3 y2 minus, so you have x2 y3. This is going to be the formula for area, but sometimes you might get negative answer. In order to avoid that, we put absolute. So if your answer is negative, you will make it positive by taking its absolute. So we are going to do one example with this formula. So let's do the example. So let's consider question 2 and its B part from 7.1. We are given with 3 points. For example, A is the point, that is a comma 2. I'll call this x1 y1, and then I have B, which is a comma 6, and C is minus 2 comma A. So let me label them. This is my x1 y1, this is my x2 y2, and this is my x3 y3. So my area is going to be 1 over 2, then x1, my x1 is going to be A, then y2 minus y3. So y2 is 6 minus y3, so it's going to be 6 minus A. Then minus, what is my y1? y1 is 2, so what I get? And then I need x2 minus x3, so x2 is A minus x3, which is minus 2, so this is plus 2. And then finally I have x2 multiplied with x3, so x2 multiplied with x3, which is minus 2a. Then I have minus, and I have x3 multiplied with x2, so x3 is, so sorry, so first this one was, let me correct this, so like let me correct now this. So you have to be careful while using the formula. So I had to write x2 into y3, so x2 was a and y3 was a, so it is going to be basically a square, then x3 and y2. x3 is minus 2 and y2 is 6, so this is going to be x3 is minus 2 times 6, so it is going to be 12. So let's simplify this more. I get 1 over 2 absolute of 6a minus a squared minus 2a minus 4, and then we have plus a squared plus 12. What we get, basically a squared gets cancelled with a squared, so area becomes equal to 1 over 2, and then we have 6a, and then we have minus 2a, so we get 4a, and then we have plus 8. So you can take 4 common and you get a plus 2, and then absolute divide by 2, which is basically 2 times absolute of a plus 2. So if a is positive, then and specifically you can write a plus 2 maybe. So that was till calculating the area of the triangle, and next session we will be, or maybe in this section we can talk about calculating the perimeters and areas of some of the specific quadrilaterals. So first quadrilateral that I will be talking about is rectangle, your famous one. So let's be more specific. Let's talk about square. So a square is a particular kind of quadrilateral whose all sides are equal. So like this, A, B, C, D. So this is going to be square if AB is equal to B, C, and then CD is equal to DA. So in this case, perimeter becomes equal to, any of the sides you calculate. Let's say you calculate AB, so that's it. If you are given that the quadrilateral is square, then you just calculate one side, and that is going to be your perimeter. So what about calculating area? So area is going to be nothing but the square of the one side, any one side you calculate. You can calculate area by squaring BC, by squaring CD, or maybe DA. So any of the side you take and square it, that's going to be your area. So how you calculate this AB? This is just distance between 2 points formula. Distance between 2 points formula. This question is asked sometimes, that show that this particular. So one more thing is, every angle is of 90 degree, and this one. So if you are asked that show that the quadrilateral is square, so you have to show that all sides are equal at least, and then you also have to show that these sides are perpendicular to each other as well, so they have 90-degree angle. Let's move to rectangle. So rectangle is going to be a quadrilateral whose all angles are 90 degree, and then opposite sides are equal. Opposite sides are equal. Lengths of opposite sides. For example, you are given with A, B, C, and D. So how you calculate perimeter? So you do what? You calculate AB plus BC plus CD plus DA. But since AB and CD and AB, these two sides are same, equal, so like this and this is same thing, so I can write 2 times AB, and then BC and DA are same, so you can write 2 times of BC, so the formula becomes 2 times AB plus BC, and these are calculated using distance between 2 points formula. How you calculate area? So area is going to be AB multiplied with CD, or maybe you can do it AD multiplied by CD, so any of the adjacent sides are multiplied. I hope that makes sense to you. Okay, so there is one other specific kind of quadrilateral that is discussed over here, that is trapezium. So let's discuss what is trapezium. The quadrilateral whose any two sides are parallel, so that is called as trapezium. The quadrilateral whose any two sides are parallel. So I must be specific that whose opposite sides are parallel is called trapezium. So that is going to be trapezium. For example, let's see some of the interesting example. One of the conventional example, traditional example that we give is going to be this one. For example, you have this where, so that is my A, that is my B, that is my C and D. So in this case, AB is perpendicular to CD side. So for example, you can have another example. For example, you have this one as, so let's say this is my A, this is my B, this is my C, this is my D. So these are typical examples. So AB is clearly, in this case also parallel to CD, for this one also, for this one also. So if opposite sides are parallel, then we term such kind of quadrilaterals as trapeziums. So how do we calculate the perimeter and the area? So perimeter is nothing but sum of all sides, as you know. So just we need to know what is area. So how you calculate area? For example, this is my trapezium. Okay, this is my AB, this is my CD. So first you label the parallel sides is base 1 B1 and base 2 as B2. So let's call this B1, this B2. You can call this B1 and this B2, no matter at all. And then you need to define height. You need to define height. What is height? So height is, any line segment that starts from this parallel line and cuts the opposite other base, the other parallel line at 90 degrees is going to be your height, that we call as h. So area becomes 1 over 2 base 1 plus base 2 into height, which is quite similar to the triangle case as well. So note that the rectangle is particular case of trapezium. Rectangle is a particular type of trapezium. Okay, I hope that makes sense, because opposite sides of the rectangle are parallel. At least two of the opposite sides are parallel. So even both the opposite sides are parallel, but we require two to be trapezium. So we can do examples of 7.1 in the next session. Wait for that.